Hello, this is lesson 8.2, solving systems of equations by substitution. We will be working from page 240, the guided practice page. So our standard today is going to be EE8. I can solve systems of equations problems using substitution. And I just want you to remember that the solution to a system of equations is an ordered pair that can be interpreted in a real-world context. So the X will represent something and the Y will represent something. So I'm going to go under the document camera to do page 240, so I'll see you there in a moment. Okay, up until this point, when we had a system of equations, we would have to graph both equations and find the point of intersection. That's what we did in our last couple of lessons. So now I was telling you that sometimes we're not always going to want to graph the equations. That takes a long time. It can be time consuming. So there is a mathematical way to do this. There's actually a few different mathematical ways to do this. So today's lesson is going to be teaching you how to use substitution to mathematically solve a system of equations. So using substitution, what I'm going to do is, if I notice, this is in standard form, right? This is in the AX plus BY equals C form, standard form. This one is in which form? Exactly, Y equals MX plus B form. So in order, before, when we had to do it, we'd have to graph them. We would put them into all Y equals MX plus B form. We'd have to manipulate that around. So now I'm going to show you how to do this. So we have Y equaling an expression here, correct? So Y is equal to this entire value. Let me put that pink here, this whole value right here. So what I'm going to do is I'm going to substitute this value, this whole expression, in for, this pink again, in for Y, because that's what Y equals, right? Y equals this amount. So I'm going to put it into the first equation like the following. So I'm going to rewrite the first equation, 3x minus 2, this means 2 times the number, right? 2 times y. Well, we're saying y is this whole thing. So in parentheses, I'm going to put 2x minus 7 in for y. That was y. Wouldn't you agree with me before? And all of that equals 9. So all I did was put this value in for the y up here. Now I have to use my fancy-dancy algebra to solve this. Before I can solve it, I notice I need to use the distributive property because I have a number in front of parentheses. So the first thing I'm going to do is that. So I have to distribute the 2 and multiply it by the 2x and multiply it by the negative 7. So be careful on this because you have some negatives here. So I'm going to rewrite this as 3x plus, and I'm going to assume this is a negative 2. So negative 2 times 2 is going to give me a negative 4x. A negative 2 times a negative 7 is going to give me a positive 14. And all of that equals 9. Now I can solve this by combining like terms. So I have my x's that are the same that have to get combined. So I have a 3x plus a negative 4x. Exactly, that'll become a negative x. I still have the plus 14 equals 9. Now remember, the goal is to get the x by itself. Do you see how when I plugged in for y, I eliminated my y variable? So I'm going to get an answer for my x, and my x will be the x coordinate that is the answer to the solution of equations. So now I have to take my 14 and get it over to this side. So I'm going to minus 14 to both sides. Hopefully this is becoming easier and easier for you. Those cross off. A positive 14 and a negative 14 is 0. I'm left with just negative x equals, well, negative 14 and a positive 9. So that is what? Negative 5, correct. However, I can't leave this negative sign here, so I'm going to divide by negative 1 to both sides. And that's going to cross off my negative signs. And I'll be left with x over 1 or just x, because any number over 1 is just the number. And then I have two negatives. Cross those will, negative 5 divided by negative 1 is going to be a positive 5. So up here in my answer, my coordinate, remember the solution is going to be an ordered pair, an x and a y point. I have my x point down here. I solved and I got 5. So that is my solution for the x value. However, I still need to solve for the y value. So now what I'm going to do is I'm going to take this 5, wait, here, so I keep bumping that. I'm going to take this 5 and I'm going to move it up and I'm going to substitute 5, so if I can get that bigger for you guys. I'm substituting the 5 in for one of the x's here, because I know that x equals 5. I'm going to substitute it in one of these equations for the x. I'm going to pick the easier equation. So the easier equation that looks to me like it's this one. So I'm going to plug in 5 for my x value. So let's go ahead and do that next. So I'm going to use y equals 2x minus 7. And I'm going to plug that 5 in. So I'm going to end up with y equals 2 times, plugging in the 5, right, minus 7. Solve multiplication first. 2 times 5 is 10. So y equals 10 minus 7. Y equals 3. So that is my y coordinate. So the answer to my system of equations is 0.53. Could I have plugged my 5 into the top equation instead? Sure, I still would have gotten 3 out of it. It's just a little more work, so I picked the easier of the two equations. So if you need to pause the video and get this down, go right ahead. We're going to go on to number 2 after this. Okay, this is number 2. And don't worry if you looked at number 1 and went, I don't know what you just did. And don't give up, because after you do a few of these, you'll see that it's going to work out and you'll get it. So let's try number 2. We have this one in y equals mx plus b, or slope internet form. This is in standard form, ax plus by equals c. So we are going to use substitution to plug in what y equals x minus 4. We're going to plug that in for y into the second equation. So if I do that, I will rewrite the second equation as 2x plus, what is y going to represent now? X minus 4. X equals 5. Okay. Now I solve. So I have an x, 2x and an x. So 2x plus x is 3x minus 4 equals 5. I need to get my 4 over to that side because I want to solve for x. So I'm going to add 4 to both sides. The minus 4 and the plus 4 will cross off and become a 0. I'll be left with 3x equals 5 plus 4 is 9. Not quite done yet. I haven't gotten x by itself. The inverse of multiplying is dividing by 3. My 3's cross off. I'm left with x equaling 9 divided by 3, or 3. So my answer is already beginning. My answer is going to be an x coordinate and a y coordinate point. 3 is my x. We just figured that out. And now we have to figure out the y. So I'm going to take this x equals 3 and plug it back into one of the equations up here. Now I'm going to pick the easier equation. So which one would be easier, do you think? I agree. This one right here would be easier. So I'm going to plug 3 in for x. So let's do that. So we get y equals x minus 4. That's what it was. So y equals, we're going to plug in our 3 for x. So that becomes 3 minus 4. So y then equals, what's 3 minus 4? Negative 1. So that is our y coordinate point, negative 1. That is our answer, our solution to our system of equations for number 2. Go ahead and pause the video if you need to. Get that written down. Okay, number 3, I'm going to leave for you to give it a try. You can either pause the video and give it a try now if you want, or you can try it at home. Your solution will end up being, well, I'm not going to tell you. I'll let you figure it out. If you want to email me, I'll give you the solution if you need it. But you're going to substitute this value in for y up in this equation. So I'm going to go on to number 4, because number 4 is a little bit different. Not much, but just a little bit. Notice how we have standard form here, standard form, ax plus by equals c. We also have standard form here. So we got a little bit of an issue because we don't have anything with y equaling something, right? So our first step then is to get one of these equations to have y equaling something. So my best bet is to pick the equation where there's no coefficient in front of the y. So this one has no coefficient, right? It just basically has a 1 in front of it, an imaginary 1. So that's the one I'm going to convert into slope-intercept form. Convert to slope-intercept form. Okay, we did a little bit of that, I think, in the last video or two. So let's convert this. So we have x minus y equals 3. So I want to get y by itself on one side. So I'm going to subtract x from both sides. So a positive x and a negative x is going to cross myself off there. No more x's on that side. I'm left with a negative y equaling 3 minus x. I do not want to keep the negative sign there, so I'm going to divide by negative 1. But remember, when I divide by negative 1 to this side, I have to divide by negative 1 to everything on that side. So negative 1 and negative 1. Which will then leave me with the two y negatives cross off. I'm left with y equaling. And then I have 3 divided by negative 1. 3 divided by negative 1, negative 3. And then, how do I do this? Well, I have a negative x and a negative 1. So plus a positive x, right? So let's switch that around so that it's in the right format. Y is equal to x minus 3. I just switched it into y equals mx plus b format. Now I have a y value for this. I just rearranged the equation. Now I have an expression, x minus 3, for what y equals. And I can plug x minus 3 into the other equation. So I'm going to go back and plug it in for y up there. So let's do that. So we have, the first equation was x plus 2y equals 6. So we're going to plug in the y value down here. X plus 2 times our whole expression, x minus 3 equals 6. First thing I need to do is the distributive property. I've got to multiply the 2 times the x and the 2 times the negative 3. Be careful when you're multiplying with negatives. Easy to make mistakes. So I have x plus 2 times x is 2x. 2 times negative 3 is negative 6 or minus 6 equals 6. Now we solve for x. Combine what we know that are the same. So this would be 1x plus 2x, 3x minus 6 equals 6. Got to get x by itself, so I'm going to add 6 to both sides. The negative and the positive cancel out. I'm left with 3x equaling 6 plus 6, or 12. Divide by 3. The 3's cancel out. I'm left with x equals 12 divided by 3 is 4. So the solution so far for our problem up here, where can I put it? I'll put the solution here. So far is 4 for our x value. We don't know the y value yet. Now we're going to take this 4 and we're going to plug it back into one of the equations up here. So I'm going to pick the easier equation. The easier equation to me looks like this one. So I'm going to put my x value in for x. So let me do that over on the left here. So I'll use a different color. I'll use green. X minus y equals 3. I'm plugging in the 4 for my x. The 4 is going to get plugged in for x. So that'll give me 4, because x equals 4, we figured out, minus y equals 3. Now we have to get y by itself, so we're going to minus 4 to both sides. And that should cross off my 4 and my negative 4. I'm left with negative y. Don't forget the negative still there. 3 minus 4. 3 minus 4. Negative 1, right? And then I have to divide by negative 1. That makes a y equaling 1. So my coordinate point then is 4, 1. That is the answer to my systems of equations for number 4. I could go ahead and graph those, and I would see that they would intersect at the x value of 4 and the y value of 1. Okay, starting with number 5, they want us to solve each system but estimate the solution first. When you do this page, you do not have to estimate the solution for all the problems. The one we're doing right now, we're going to estimate, and that will be good. Okay? You don't have to estimate them for all of them. So because I'm going to be estimating first and kind of doing a rough graph of something, because we're going to estimate to see about where the point of intersection is to see if we're kind of getting it right. Like I had showed you in the previous videos, we can always check that point that we come up with by plugging it back into both equations and making sure we have true statements. But let's do what they're saying here and estimate. So I'm going to pick some x values and you see what kind of y values it yields. So here's my first equation, here's my second equation. So I'm just going to plug in, I'm going to put in the values, let's see, negative 1, 0. You can pick any numbers you want. I'm going to try those 3 just to kind of give me a range. And if I do that and I plug that in, I'm going to have 6 times, plugging in negative 1 for x, plus y equals 4, solving to find out what y is. So 6 times negative 1 is negative 6, plus y equals 4. I'm going to add 6. These are going to cross off. I'm going to be left with y equaling 10. So that value is 10, that first point. I'm just going to get a couple of points so I can graph it. Then I'm going to plug in 0 into the same equation. 6 times 0 plus y equals 4. 6 times 0 is 0, so we have y equals 4. So 4 is our value for that one. And then the last one I did is 5, so it's going to be 6 times 5 plus y equals 4. 5 times 6 is 30, plus y equals 4. I'm going to subtract 30 from both sides. If you guys are not real solid on the manipulation of numbers in an equation, go back and watch one of the previous videos. I'm going to go along a little bit faster now on some of this stuff that we should already be pretty good at. So y is equal to 4 minus 30. So that's like 30 minus 4, isn't it? Negative 26. So negative 26 up there. So we have some points for graphing. We'll do that in a minute. We still got to do the second equation. So this is why I'm not going to have you guys estimate on all of these problems, because this will take you hours to do your homework. We don't want that. So I'm going to pick the same points, negative 1, 0, and 5. This time I'm going to plug it into the other equation. So we have a negative 1 for x, negative 1 minus 4y equals 19. And I'm going to move the negative 1 to the other side by adding a positive 1. These will cross off. I'm left with negative 4y equaling 20. I'm going to divide by negative 4 to both sides. Can't see that. Now you can. These cross off. I'm left with y equaling negative 5. 20 divided by negative 4 is negative 5. I'm going to put that up here in my chart. Okay, I got to do that 2 more times. So I'm going to plug in 0 for my x. Can't see that. Plugging in 0 for my x this time from the table. So I go down here and I say 0 minus 4y equals 19, which is negative 4y equals 19. Divide by negative 4 to both sides. The negative 4's cross off. I'm left with y equaling negative 19 divided by 4 is negative 4.75. So negative 4.75 is going up in the chart. The last one I want to plug in is 5. So I'll find a spot on my paper here. 5 minus 4y equals 19. Move the 5, minus 5, minus 5. These cross off. I'm left with negative 4y is equal to 19 minus 5. 14. Divide by negative 4 to both sides. I'm out of room here. So these cross off. I'm left with y equaling 14 divided by negative 4. It's hard to tell. That's 14 divided by negative 4, which turns out to be negative 3.5. My chart. Okay, now that I've got my points, I'm going to do a rough estimated graph to see that when I solve by substitution that I'm getting about the right answer. So all of that work, let's go ahead and graph. I'm going to try to leave my tables here somewhere. Let's fold this one. Maybe if I fold this over, have enough room to fit it. And I'll just move this for now. Okay, so we have our tables of values. I guess you can't really see that too good. Put it on the side. So let's just do these first. We have negative 1 and 10. So we're going to find negative 1 and 10. I went up by 5s on the y-axis. And then we're going to plot 0 and 4. 0 and 4 is going to be about here. 5 and negative 26. 5, and then we're going to go all the way down to about here. And then we would take our ruler and graph that. I love math. Don't you guys love math? It's actually very fun. Okay, that one was the first one. That was the table, this one right here. So that is 6x plus y equals 4. Make sure I label my line. Now we're going to plot these points here. Do that in green, I guess. So we have negative 1, negative 5, negative 1, negative 5, 0, negative 4.75, 0 and negative 4.75 is about there, and 5 and negative 3.5, 5 and negative 3.5. We don't have to be exact like we had to on the last unit because this is an estimate, remember. So that one is x minus 4y equals 19. Okay, and this is our point of intersection. About what is that point, do you think? Estimate that point. Well, it's about 1, right? About 1. My dot's a little big. It's a little past the 1, so it's approximately past the 1 a little bit, 1 point something. And the y value is somewhere up on less than -5, right? So we'll say less than -5. So this is going to be what we're looking for when we do our substitution to get an answer that's somewhat like that. So we'll come back and check and see if we did that when we get our substitution. So now let's go back to where it happened to the problem. Oh, I folded it over. Yeah. Okay, so here's our problem, our original problem, and then we're going to use substitution to solve it. So I'm just going to take a whole new piece of paper here because that one is full. Let's solve it by substitution. So we have 6x plus y equals 4 and x minus 4y equals 19. One of these has to get put into the format y equals mx plus b. Which one looks easier? Kind of a horse apiece in a sense. I'm going to use this one because it has a coefficient of 1 in front of it. So it's easier. I have one less step. I don't have to divide at the end by the number in front of the coefficient. So that's the one I'm going to change into slope-intercept form. So 6x plus y equals 4. I'm going to subtract 6x from both sides. I'm going to end up with y equals 4 minus 6x. And then I want to rearrange that into y equals -6x plus 4, y equals mx plus b format. Now I'm going to take this whole expression and plug it into the other equation for y. So let's go ahead and do that. So we have x minus 4y equals 19. We are going to plug it in. So we're going to end up with x minus 4 times, oops, I'll put that in pink, 4 times the expression -6x plus 4 equals 19. We must use the distributive property first. Be careful, I'm going to change this to an x plus, call that a -4. -4 times -6 is going to give me a positive 24x. And then a -4 times a positive 4 is going to give me a negative 16, all equals 19. So now I got to combine my two x's. So that's 25x minus 16 equals 19. I'm going to add 16 to both sides. Don't lose me now. 25x is equal to, these cross off, 19 plus 16, 35. And then I'm going to divide by 25 to both sides. If I do that, and take my calculator, if you would rather use long division, you can go ahead and do that if you need practice. 35 divided by 25 is going to be 1.4. So x is equal to 1.4. And you can't see that. There, x is equal to 1.4. Let's double check that with our graph. Where did our graph go? Let's see what our value had to be in for the x. So we had come up with an estimated value of 1 point something. We came up with our x value being 1.4. So we did it right. We estimated and we were close. We were close on our estimate and we were exact on our x value. So now we have to do this for the y value. So let's pull this graph out of here for a moment. Go back now. The whole thing back. We have to plug in this value for the x in one of our problems up above. I think it'd be easier to plug it in for this x, this equation. So that's the one I'm going to use. Same one I just used, isn't it? Yep, doesn't matter. So x minus 4y equals 19. I'm going to plug in, back here now, I'm going to plug in this 1.4 up there. So 1.4 minus 4y equals 19. I'm going to move the 1.4 to the other side by subtracting 1.4. These cross off. I'm left with negative 4y equaling 19 minus 1.4. 19 minus 1.4, 17.6. 17.6. Divide by negative 4 to both sides. Y is equal to 17.6 divided by negative 4. Calculator out. 17.6 divided by negative 4 is negative 4.4. Negative 4.4. That's our Y value. Now let's just check that and see on our estimate if that's what we got. So we said in our estimate that the Y value was going to be less than negative 5. And it is. It's negative 4.4. Or is that greater than? Greater than negative 5. Greater than negative 5. Should be greater than. I'm going up. So negative 4.4 is right on. So our solution to our substitution equation, a system of equations, is 1.4 is our x value. Negative 4.4 is our y value. Now, if I wanted to check that, I didn't want to graph it and I wanted to check it, I could plug in these numbers into both of the original equations and see if they become true. I'm not going to go through the whole process, but I'm going to show you what you do. X minus 4y equals 19, and x minus, what was the other one? 6x plus y equals 4. The original problem, and I would just plug in 1.4 and negative 4.4 and solve, and I should yield a true statement. And if I yield a true statement, then I have the correct intersection point. Phew, that was a lot, wasn't it? Okay, let's go ahead and do number 6. I'm not going to do all of the guided practice problems today because our video would get way too long. But I am going to do number 6, and then I want to do number 9 with you guys. And then I will show you your homework, and then the video will be done. So we have to, they're both in standard form. We have to get one of them into y equals mx plus b form. I'm going to use this one. It seems easier. Could use the other one just as well. So in order to get that into y equals mx plus b form, I'm going to manipulate the equation using my algebra skills. So I want to get y by itself. So I'm going to subtract x. If I do that, the x's cross off. I'm left with 2y equaling. And now that I know this is really 8 minus x, I'm going to rearrange it right away and go negative x plus 8. So that it's in this format right away. Now I'm just going to divide by 2 to everything on the other side. The y's cross off, the 2's cross off. I'm left with y equaling. This is the same as a 1 in front of the x, right? So it's really negative 1/2 x. That's the same thing. And then 8 divided by 2 is 4. Okay, so now I'm going to use substitution. And I'm going to take this y and I'm going to plug it into this whole expression. I'm going to plug it into my other equation for y. So if I do that, I'm going to get 3x plus 2 times negative 1/2 x plus 4 equals 6. Do the distributive property first. So we'll get 3x plus 2 times negative 1/2. It's going to be a negative what? Negative 1, right? X. 2 times 4 is 8 equals 6. 3x plus 1x is 2x. Plus 8 equals 6. Move the 8 to the other side. 2x. Moving it over here becomes a negative 8. They cross off. 2x. Move it down. 2x is equal to 6 minus 8 is negative 2. And now I divide by 2. X is equal to negative 1. So that's my X solution. Can I write that? Up here, I'll put negative 1. Don't know what the Y value is yet. So I got to plug my value for X back into my equation, one of the other ones, doesn't matter which one. So if I go back up here, the easier equation to plug negative 1 into, to me, looks like this one. So I'm going to plug it into that one. So I have X plus 2Y equals 8. And I'm going to plug my negative 1. Oh, I wanted to use pink. Plug my negative 1 in for X. So negative 1 plus 2Y equals 8. Going to move my 1 to the other side by adding inverse operations. That crosses off. I'm left with 2y equals 9. Divide by 2. Those cross off. Y is equal to 9/2. So what is 9 divided by 2? Well, we can leave it like that, or we can make it a decimal. So if I wanted to make it a decimal, 9 divided by 2 would give me 4.5, or I can leave it as that, but I'm going to say 4.5. And I'm going to go put that back into my solution up here, 4.5. Negative 1, 4.5. Now, if I wanted to check that I did that right, I would plug this back in for each of these equations. I'd plug X value in, and I'd plug the Y value in and see if it yields a true statement. Plug the X back in, plug the Y back in, see if it becomes true, like we did in our last video. Go ahead and watch the last video if you need to see how to check those. So that's number 6. I'm going to leave you to do number 7 and number 8 on your own. You can always email me or pop in during one of the pop-in sessions. And I would like to do number 9. This is my last one here. I think I'm actually going to need, I'm going to do number 9 because this is like the last lesson, only this time we're armed with our substitution method to solve this mathematically instead of having to graph it. So let's read it. Adult tickets to Space City Amusement Park cost X dollars. Children's tickets cost Y dollars. So adults are X, so let X equal adult tickets, or the cost, adult ticket cost. And then children's tickets cost Y dollars, so let Y equal children's child ticket cost. Child ticket cost. The Henson family bought 3 adult and 1 child ticket for $163. The Garcia family bought 2 adult and 3 child tickets for $174. So the question on A says, write equations to represent the Henson's cost and the Garcia's cost. Henson's cost and the Garcia's cost. Okay, Henson's cost, they bought 3 adult tickets. So we'll see if I have room here. Henson, this is A now, number 9A. Henson's cost, This is their cost, right? Times 3 adult tickets, right? And they bought 1 child ticket, 1 Y or just Y. And altogether they spent $163. Okay, Garcia, they bought 2 adult tickets and 3 child tickets, and they spent $174. We now have our system of equations. So that's the letter A answer. Now we have to solve for X and Y to get our system of equations answer, because what does it say? What just says solve the system? So we're going to find the adult price and the child price. We're going to find the X, and we're going to find the Y. So I need another piece of paper, or part of a piece of paper here. Do this. Okay, got a little bit more room now. Okay, so let's solve this. Let's put a little bracket around it. It's our system of equations. So we have to get one of them with a y by itself, y equals mx plus b format. They're both in standard form. This one doesn't have a number in front of it, a coefficient in front of it. So that's going to end up being my one that I'm going to manipulate into y equals mx plus b. So we're going to take 3x plus y equals 163. And we're going to have y by itself, so we're going to subtract 3x from both sides. 3 x's will cross off. Hang in there, guys. We're almost done. Y is going to equal, and I'm going to reverse it so that I have my x value first, negative 3x plus 163. And that's all I have to do, right, for that? That was an easier one. Now I have to take what my y value is, this whole expression, and substitute it into the other equation, or the y value. So let's do that. So the Garcias was 2x plus 3y equals 174. Let's plug this expression in for y. So we have 2x plus 3 times negative 3x plus 163 equals 174. Use the distributive property to multiply. So that will give us 2x plus 3 times negative 3x is negative 9x. 3 times 163. I'm going to use my calculator for that one. 163 times 3, 49. By the way, when you get into this higher math, the calculator is going to help you a lot so that you're not wasting a lot of time on smaller things like multiplying numbers. 174. Because you got all this other stuff to do now with math. So now we're going to take our 2x and our negative 9x, and that's going to give us negative 7x plus 489 equals 174. And now I'm going to move my 489 to the other side by subtracting 489. These will cross off. I'm left with negative 7x is equal to, okay, I got a negative 489 and a positive 174. So that's the same as saying I owe somebody $489, but I pay them $174 of my debt. I am now still in the negative, but not very much, right? Not as much. Negative 315. Now I'm going to divide by negative 7 to both sides. That'll get rid of my negative. Because in the context of this problem, if we end up with a negative answer, that wouldn't make sense, right? Because X stands for adult ticket cost. Well, you can't have a negative cost for a ticket. So now we take 315 divided by 7. We get 45. So that represents, go back up here, X is the adult ticket cost. So the adult ticket cost for letter B is $45, dollar sign in front of it. So that's the adult ticket cost. Now we got to find the child ticket cost. Well, how do we do that? You plug back in the $45 for X into one of these equations. I'll plug it into the first equation. So 3x plus y equals 163. Doesn't matter which equation I choose. I'm going to plug $45 in for X. If I do that, I get 3 times 45 plus y equals 163. Move that up a little bit. 3 times 45, 135 plus y equals 163. I subtract 135 from both sides. Y is equal to 163 minus 135, 28. So that means that a child's ticket cost, remember what Y equals, a child's ticket cost? So a child's ticket is $28. Child ticket cost. So there we are. Okay, we are back to the time where we show your homework. So go scroll down here. Your homework is going to be to finish guided practice, page 240. I did most of the problems. There's a few I'd like you to try on your own. And then page 241 to 242, do numbers 11 through 15. If you have any questions at all, please email me. The math is definitely getting up there in difficulty. So this is stuff you're going to be seeing in high school. So it's a really good idea to get a good handle on it now. So we'll talk to you next time. Have a good day. Bye.